Welcome back. As promised, we're going to take a look at another way to solve quadratic equations when you can't factor it. And to do that, we're going to look at the same function, y equals negative x squared plus 12x minus 20. But now we want to figure out the x values, and again, we know that there are two, when y is equal to 10. Okay? So we can see here that our answers are not going to be, at least as far as this graph can tell us, not gonna be some nice number. It might be like 3.5 and I don't know 8.5 as far as I can tell, but again, because it's a graph, I can't quite be super precise with that. So I'm gonna set up our equation just like we did last time. So we have, let's see, y is equal to 10, so now I'll replace the y with the 10. You get y equals negative x squared plus 12x minus 20. Excuse me, and I'm gonna make, just like last time, I'm going to try to get one side to equal 0 and try to factor it. So I'm going to do that this time by moving all of this to that side, which it ends up being the same thing. We'll end up with positive x squared, so I'll add x squared to both sides. I'll subtract 12x from both sides. And then I'll add 20 to both sides. So I'll get plus 30, or end up, that's what this will be. Is equal to 0. Okay. Okay, so let's try to factor this now, and well, obviously I don't think it's going to be possible based on the title of this video, but yeah, so if I'm going to try to factor this, I need to get, let's see, x squared and 30, so I need two numbers that multiply to 30 and add up to 12, and I don't think that's going to be possible. Because for 30, well, how can we do it? We can do 5 and 6, 10 and 3, 1 and 30, or I guess 2 and 15. Or sorry, yeah, 2 and 15. I don't think we have any other options, and none of these are going to add up to 12. So this, as far as I can tell, I think anyway, this is unfactorable. Okay, so we got to go back to the drawing board. Okay, so let's step over here. Oop, grab that. There we go. Okay, so let's try this, and we've seen this before where, okay, so if the thing wasn't factorable and I needed to find, say, the vertex, that's what we did before, I would do it by completing the square. Now, there's no y here, so you're not exactly, putting it into vertex form, but it is going to look similar to vertex form. Okay, so we are going to work that same process. Now, remember, the way I like to do it is by getting rid of this constant term here. So I'm going to add 20 to both sides. Okay, so, excuse me, pause this real quick. Okay, sorry about that, folks. I realized I was playing music in the back and I wasn't sure if my microphone was picking it up, and then if there's music playing during the video that I don't have the rights to, then it's a whole thing. Okay, so I added 20 to both sides, just like I would normally when I'm completing the square. I'm also, you can see here that there's also a negative 1 in front of our x squared, which we don't want, because that makes your completing the square kind of messy. So I'll get rid of that by multiplying, again, the entire equation by negative 1 to get rid of it, just like I did on the other side, or in the last video, actually. So I'm going to multiply by negative 1. Oh, so, oops. Negative 1. And, again, on this side, too. So we'll get negative 30 now is equal to x squared minus 12x. This just makes my life a lot easier, and this is a little preview as to generalizing the completing the square process. Okay, so I'll draw the picture one more time here, and some of you might be tired of seeing the picture here, but I'm going to draw my x squared there. Let's see, I have 12 x's to split up, negative 12 of them, so I'm going to split them up evenly to make a square again, negative 6x, and negative 6 of them down here. So I can already tell this is going to be x minus 6 by x minus 6. And the amount that I need to add in to finish this, negative 6 by negative 6, or 36. So I'm going to add in 36 on the left side and the right side. Okay. So now we will end up with 6 is equal to x minus 6 squared. Again, 6 from negative 36 plus, sorry, negative 30 plus 36. And again, this is an equation that we can now solve. So do not, at this point, expand the right side and then, go about trying to factor it, because we've already proven that this equation is unfactorable. Okay, but we can do this by taking the square root of both sides. Okay, so I'll take the square root of this and the square root of this, and the square root of 6 is a number. It's whatever it is. It's 2 point something. But that's all it is. It's just a number. So I'm just going to leave it as the square root of 6. Oops, I don't know why I changed colors. The square root of 6 is equal to x minus 6. But remember, you get two answers because just like how the square root of 9 is 3 or negative 3, the square root of 6 is 2 point something and negative 2 point something. And so the way I'm going to write that is that, or negative 6. Sorry, the negative square root of 6. It is not the square root of negative 6. That'd be very different. Is equal to x minus 6. Okay. Now that we have this, now we can solve and eventually we will get a decimal approximation here, but we'll do that by adding 6 to both sides. Plus 6 here, plus 6, and plus 6. And you'll get two answers. You get either x is equal to, so I usually put the square root second in the expression, so I'll say 6 plus the square root of 6, or 6 minus the square root of 6. And the way you can abbreviate this, get a little bit faster, you can simply say x equals 6 plus or minus the square root of 6, and that's what that means. Again, this just means you have two answers, but I'm just too lazy to write it out twice. Now, if I want a decimal approximation, I can pull up my calculator here, and if I do 6 plus the square root of 6, I end up with about 8.45, which is one of them, which again, it looked like it was about 8.5-ish. Or if I do 6 minus the square root of 6, I'll get about 3.55-ish. Again, like we kind of expected, right? So that's where these points are. This point right here is about 3.55, comma 10, approximately. And this point right here is approximately 8.45, comma 10. Alrighty, so that's how you can use the idea of completing the square to solve an equation. Now this is really nice because if you saw before, when factoring, you're really kind of hoping you get lucky and that the expression you get is actually factorable. That's not always, clearly that's not always going to work out. But completing the square always does work. Again, this kind of works because you're essentially putting the equation into vertex form, and again, every parabola has a vertex form. So complete the square always works. It's just an uncomfortable process for a lot of people, and they prefer to factor it whenever it's possible. So if you were gonna kind of just stick with one way and always do that one way, I guess technically you would be better off with completing the square because you always can do it. Okay, so hopefully this helped, and hopefully you feel now empowered to solve any quadratic equation that you might come across. I will say this, you might have heard about this thing called the quadratic formula, and the quadratic formula is really just a generalization of completing the square. Okay, so if you can complete the square, you can use the quadratic formula because they're really the same thing. Alrighty, so thanks for watching, and I hope this helped, and I'll see you next time.